This is video number 2 from the 4.2, 4.3 sine, cosine, and tangent on the unit circle. Alright, so right now we're looking at this special right triangle, this 30, 60, 90 right triangle, and we're calculating the cosine, the sine, and the tangent. Again, remember that cosine is adjacent over hypotenuse. So for the 30, I went to the adjacent side, which was the square root of 3, over the hypotenuse, which was 2. For the sine, that's opposite over hypotenuse. Opposite is 1, and the hypotenuse is 2. So I get 1/2. The tangent is opposite over adjacent, which would be 1 over the square root of 3. I'm going to write that off to the side right here, because I can't have a radical in the denominator, so I need to do what's called rationalizing the denominator, and I do that by multiplying by the square root of 3 over the square root of 3. You might wonder, well, why are we allowed to do that? Because this is just a giant number 1. I'm just multiplying by 1, so I'm not really changing the value. I'm just changing the look of the number, and I get the square root of 3 over 3. Now let's go to my 60. So now I'm looking at my 60-degree angle, and oh, by the way, I forgot to write here, this was opposite over adjacent, opposite over adjacent. 60. I'm now going to do the cosine, which is adjacent, which is 1, over hypotenuse, which is 2. The sine is going to be opposite, which is the square root of 3, over the hypotenuse, which is 2. And the tangent is opposite, square root of 3, over adjacent, which is 1. So square root of 3 over 1, or just square root of 3. For a 45-degree angle, I'm going to look at my 45, 45, 90. And again, you should have learned in geometry that across from the 45 is x, and they're the same because they have the same angle. The lengths of the sides must be the same, and the hypotenuse is x times the square root of 2. And because I'm on the unit circle, I'm going to replace those x's with a 1. So I simply get 1, 1, and the square root of 2. So for my 45-degree angle, and this is my hypotenuse, adjacent is 1 over hypotenuse is square root of 2. So the cosine of 45 degrees is adjacent, which is 1 over the square root of 2. So when I have 1 over the square root of 2, I have to rationalize this denominator. You're not allowed to have a radical in the denominator. So I multiply by the square root of 2 over the square root of 2, which is just a giant number 1. And I get the square root of 2 divided by 2. When I go to do the sine, opposite over adjacent, I get the same thing, 1 over the square root of 2, which is going to simplify to the square root of 2 over 2. And for the tangent, I get opposite over adjacent, which is simply 1. Then I'm going to move down here, and I'm going to practice a little bit more with my table. My suggestion to you would be to see if you can look at this little picture. Imagine that the unit circle is right here. Okay, and cosine, remember, is the x coordinate. And so I'm going to look at just my x coordinate going around. So I'm going to look at my 1, then my 0, then my -1, then my 0, then back to my 1. And I'm going to simply fill that in. So my x coordinates are 1. At the 90, it's 0. At the 180, it's -1. At the 270, I'm at 0. And at the 360, I'm back to 1. Sine is my y coordinate. And so I'm going to look at just my y's. 0, go up here, 1. My y coordinate at 180 is 0. At 270, it's -1. And at 360, I'm back to 0. And I have to remember that tangent is y divided by x. So it's y divided by x, 0 over 1, which is 0. 1 divided by 0, which is undefined. 0 divided by negative 1 is 0. Negative 1 divided by 0 is undefined. And 0 divided by 1 is 0. I'm going to go ahead and put those here. It's 0. This would be undefined. This would be 0, and this would be undefined, and back to 0. Okay, so I'm going to draw myself a little unit circle here where I have the ordered pair 1, 0, 0, 1, negative 1, 0, because remember this is the origin, and this would be 0, negative 1. This is 0, 90, 180, 270, and 360. If I was to write this in radians, this would be 0, this would be pi divided by 2, and this would be pi. This would be 3 pi over 2, and this would be back to 2 pi. Because remember, all the way around is 2 pi, so this is half of a pi. I'm sorry, this is pi, this is half of a pi, this is 1.5 pi, this is 2 pi. So sine of 270, I have to remember that all of my ordered pairs are cosine, sine. So sine of 270 is the y-coordinate at 270. The y-coordinate at 270 is negative 1. Then cosine of 270 would be my x-coordinate, which would be 0. And my tangent, we have to remember, is always sine divided by cosine. So negative 1 divided by 0, which is undefined. All right, at negative 3 pi, let's talk about where that would be. This is 0, 1 pi, 2 pi. This would be 3 pi. Negative 3 pi is just going to be going the other direction. Negative 1 pi, negative 2 pi, negative 3 pi. So right here is negative 3 pi. And sine is the y-coordinate, so it's 0. The x-coordinate is negative 1, and the tangent is 0 divided by negative 1, or 0. The sine at 0, that's right here. Sine is the y-coordinate, 0. Cosine is the x-coordinate. Tangent is sine divided by cosine, which is 0. Next part. It says describe all values excuse me, of theta between 0 and 2 pi that satisfy the given requirement. Right. One of the things we have to realize in my unit circle, where I have 1, 0, 0, 1, negative 1, 0, 0, negative 1. This is the origin, 0, 0. This quadrant here is positive, positive, which means cosine, sine is positive, positive. This is my negative, positive quadrant. X is negative, y is positive. So cosine, sine. Cosine is negative, sine is positive. This is my negative, negative quadrant, which means cosine, sine, negative, negative. And this is my positive, negative quadrant, cosine, sine, which is positive, negative. And the first question, number 5, says, where is my cosine of theta negative? The cosine of theta, what I'm going to do is I'm going to draw a picture and divide it into 4. My cosine is negative here and here on the left side of the circle. I'm going to shade it in lightly. My cosine is negative here, and it's negative here. And where is my sine greater than 0, which means positive? Sine is positive here and here. So my sine is positive in the top. And where did I overlap? I overlapped right here. Now, since we're talking pi here, I have to realize that this, at the top of my unit circle, this is 0, this is pi, so this is pi over 2, and this is pi. So theta is going to be between pi over 2 and pi. Because remember again, if you need to draw this, just to remind yourself about your radians. 0, this is pi, this is 2 pi, which makes this half of a pi, and this 3/2 pi, or 1.5 pi. Okay? All right, so for number 6, again, I'm going to draw my circle. Last year was when I started having students do this, and everybody started getting these right. Before that, these kind of questions everyone got wrong. It's real easy to just draw your circle, divide it into 4, and think to yourself, where is the sign less than 0, which means negative? Sign is negative here and here, which is the bottom half of the circle. And the tangent is less than 0, which means I'm going to need to calculate my tangent. So tangent is y divided by x, so positive over a positive is a positive. Positive over a negative is a negative. Negative over a negative is a positive. And negative over a positive is a negative. So where is tangent negative? Tangent is negative here and here in diagonal quadrants. And my overlap happened right there. And that is from 3 pi over 2 to 2 pi. All right, let's go to my next one. Draw my circle. Where does my sign equal 0? That's my y coordinate. I have a 0 here, and I have a 0 here. And then where is my cosine greater than 0, meaning positive cosine? Cosine is positive here and here on the right side. So the overlap is just here on the right side, just where this dot is, and that's where theta equals either 0 or 2 pi, because right here on the right side of the circle, theta has 2 names. All right, number 8. Where's the tangent negative? Because that's less than 0. That's in these diagonal quadrants. Where's the cosine less than 0 or negative? Cosine is negative here and here on the left side. So my overlap is right here, starting at pi over 2 and ending at pi. Lastly, you're supposed to estimate where would negative 270 be? Well, 270 is here, so negative 270 is up here, and sine is the y coordinate, so that's d. Cosine of 13 over 12, well, 12 over 12 would be 1 pi, so 13 over 12 would be a little farther, and cosine is x, so that's g. 135 is right around here, and the cosine is x, so that's e. Sine of pi over 3. Well, this is pi, so a third of the pi would be right around here, and sine is the y coordinate, so that's b. That's negative 2 pi over 3. So let's see. 2 pi over 3 would be 2/3 of a pi this way, so 2/3 of a pi this way. I've got to think, is this, I'm thinking this is more like 6. Maybe this is going to be my 2 pi. Sorry, I didn't have it moved up, I just realized that. But 2/3 of a pi, negative 2/3 of a pi, and the cosine is the x.